Hi one and all. So in this video I'm going to explain the design part that has to be carried out by a student for carrying out the experiment titled as design of sequence generator. The aim of this experiment is you need to design and set up a generator called sequence generator using IC 7495, which is basically a 4-bit shift register, right? So what you will be given in the lab is you will be given a sequence. Okay, you will be given a sequence like this. This is an example for a given sequence. So the faculty will give a sequence in the lab. Usually this sequence will be in terms of zeros and ones. Okay, so let us assume that in this case the given sequence is 1 0 0 1 0 0 1 0 1 0 and 1 1. So first what the student has to do is they have to go through the given sequence. As I said, usually it will be in the form of zeros and ones. Okay, and they have to find out the length of this given sequence. So length is nothing but the number of bits present in the given sequence, or in other words the number of digits present in the given sequence will give you the length. Okay, in this case the length of the given sequence is 15-bit. So this is the first step what the student has to do before carrying out the experiment titled as sequence generator. Then what they have to do is, then in the next step in the design part, so they have to come up with a table like this. Okay, they have to write a table, okay, like this. So QA, forget about clock for the time being, forget about map value for the time being. So first they have to write QA column, QB, QC and QD. So for the time being, again forget about the output column called D. So now what they have to do is they have to go through the sequence first, and they have to copy the given sequence, okay, in the QA column first. So this is the first step what the student has to do in the design, in filling this table is, so they have to copy the given sequence to the QA column. So how they have to copy, see here, the first bit given in the sequence is 1. So write down 1 first. Then the next bits given in the sequence are 3 zeros, 0 0 0. Then write 0 0 0, 3 zeros. Then 1 0 0. Then 1 1 0 1 0, 1 1 0 1 0, then finally 1 right? So what they have to do in filling this table is, so first they have to have a table with 4 columns labeled as QA, QB, QC, QD, and then they have to fill, remember, the first column, QA column, with the given sequence, okay, with the given sequence in order, right? Then what they have to do is, then they have to write constant 1 in the first row in the QB column. Then they have to fill the other rows of the QB column with the given sequence, and stop at row number 15 itself. You no need to continue with the row number 16. Obviously this will these rows will be don't cares. So forget about don't care conditions. So just fill it up to the 15th row. Clear? Okay, so if you have not got an idea at this point, just watch the sequence. The sequence is 1 0 0 1 0 0. See here, 1 0 0 1 0 0 1 0 1 0, then 1 1. So obviously the last one will come here, but you need to focus up to row number 15. That is sufficient. You can ignore this because the length of the given sequence is 15, right? So next what you have to do is, now you need to fill QC column, where you need to fill the first 2 rows with a constant 1, then fill the other rows of this table for the QC column with the given sequence in order, right? So the given sequence is 1 0 0 1 0 0. See here, 1 0 0 1 0 0 1 1 0 1 0, like this, and you can ignore the rest of the bits. Similarly, you fill the QD column where the first 3 rows will be filled with constant 1. Then you filled the other rows of the QD column with the given sequence in the order, right? Up to row number 15. Clear? So after this you need to fill the output column. We have labeled the output as D here. In this case you can label it as E, Y as you wish, right? So now interesting how to fill this output column is, so what is the first bit in the given sequence is 1, right? So first write the first bit in the given sequence here 1, then you need to fill this column in this order, then 000, because 000, so after 1 there is 000 here, so 000, then after 000 100 again, so 100 11 010, then 111. So this is how you need to fill the output column. So first fill the last row first with the first bit in the given sequence, then you need to go ahead with filling the D column or the output column with the given sequence after, from the second bit. See here 0 0 0 000 10, like this. So this is what you have to do. So clear up to here? Now what you have to do is, the next step is you need to find out the Boolean expression for output D in terms of QA, QB, QC, QD using this table, right? Why we have to do this? We need to find out the Boolean expression so that we can able to come up with the final circuit diagram for the given sequence, which will act like a sequence generator. Clear with this? How to do this? We know that we can able to do this with the help of KMap, right? With the help of KMap. So in this case, we are, how many rows are there? 15, right? So obviously in the KMap we should have 16 cells, right? Yeah, I hope you people are familiar with the KMap, right? So, and here the design variables are, I will take A here, B here, C here, QD column here. So you know how to give the row numbers: 0 1 1 1 1 0. Similarly here 0 0 0 1, then 1 1 1 0, right? So what is the cell number? Cell number 0 1 2 3 4 5 6. I am writing cell number here. Don't these are not values. 7 8 9 10 11 12. You will understand why do we need this. 12 13 14 15, right? So this is how you need to write the KMap. So why we have used this KMap? So to get the to get the simplified expression, particular Boolean expression for output D in terms of A, B, C, D. Make it simple, or more specifically QA, QB, QC, QD. Now focus on this particular column. See, map value is nothing but the decimal equivalent of the binary value from QA to QD. See, for example, so if this is the binary value 1 1 1 1, what would 1 1 1 1, decimal equivalent of this binary is 15, right? For the time being, again forget about the clock column. Again look at here, 0 1 1 1 is a binary value, decimal equivalent of this is 7. So 0 0 1 1 is the binary value, decimal equivalent of that is 3. Okay, like this you write the decimal equivalent for the binaries for a column starting from QA to QD, right? So you will understand why it is so. See, it will be useful if you do this. It is easy for you to fill the KMap cell values, right? So look at here, whether there is a decimal value called 0 here, no. So hence it can be don't care. So don't care means either it can be 0 or it can be 1. I will take this as a 0. I will take that as a 0 value, right? 0. Okay, now what is the now we shall fill this particular cell value. Cell value is 1. Look at the value 1 here. Yeah, there is a value 1 here. Then in that row, what is the D value? What is the D value? 1 here. So you need to fill 1 here. Okay, then we have to fill the cell value 2. Look at row number 2. So what is the D value here? 1. I hope you are getting the things. Okay, then cell value is 3 here. Then row number 3 here. What is the decimal value? Sorry, what is the D value? 0 here. And cell value 4 here. So look at row number 4. And what is the D value here? 0. Then fill 0 here. And 5, So look at row number 5. So this is row number 5. What is the D value there? 1. So 1. Then look at 6. Okay, 6 row number. What is the D value? 1 there. Then 7. Then 7 here. What is the D value? 0. Similarly, look at for 12. 12. Where is 12? Here it is 12. It is 0. D value is 0. Then when it is 13. When it is 13, D value is 1. 1. Then what about 14? It is 1. What about 15? What about 15? It is 0. 0. What is about 8? 8. 0. 9. Row number 9, it is 1. Row number 10, it is 1. Row number 11, it is 0. So if you have written a map value for the binaries, then it is easy, or it will take less time to fill this KMap. Clear? So that's why we have written map value here. Now you need to apply the formulas of KMap in order to get the simplified Boolean expression for the output D in terms of QA, QB, QC and QD. So if you have remembered the grouping rules, so I can group these 4 ones into a single group and these 4 as a single group. So we have 2 groups here. Then what is the Boolean expression for this group? It is C bar and D, right? Because it is 0 and 1. So I have taken QC and QD, since that's why this will become, that Boolean expression will become C bar D, and I am trying to get min-term expression. That's why I am treating 0 as bar. Now it is, for this group it is 1 0. 1 0 means C is 1, D bar. So what is C bar D plus C D bar? It is nothing but C exclusive OR of D, right, which you have learned in the theory classes. It is nothing but C exclusive of D. This is a simplified Boolean expression for output D in terms of the inputs. Like I can call this as an QA, QB, QC, QD as inputs, right? So now what you have to do is, once you get this as a Boolean expression, now what you have to do is, you need to come up with a final circuit diagram. See, in the manual before going to that point, they have done the simplification using the KMap cell, but by taking the input order as QC, QD first and QA, QB, either you can do this or you can follow the approach which I just now explained a few minutes back. Clear? Even if you done like this, you will get the same expression. Okay, clear with this? Clear? Okay, now this is the final circuit diagram for the sequence generator. See, since we found out the required sequence, I mean output Boolean expression for the output D is nothing but, can you see here, it is nothing but C exclusive of D. That's why we are passing C and D as an input to the exclusive OR gate, and that output I mean the required sequence we will get at pin number 3 of XOR gate, and we have to supply that as an input, serial input again, to get the next value to the circuit. Clear? Okay, these are nothing but the parallel inputs. This is serial input, this is serial clock, parallel clock and mode control, which will control the mode of the operation, serial mode and parallel mode. There are 2 modes in which this shift register can work, and obviously 14 for voltage pin and 7 for ground, right? Okay, so the using this circuit diagram you need to do the connection, and how to verify your connection is with the help of this truth table. See, with the help of this truth table, same truth table. Now what you need to do is, first you need to make that shift register or this circuit. First you need to make this circuit to work in parallel mode first. I have explained even in the previous video and even in the laboratory how to make the shift register to work in the parallel mode. Just supply mode control value as 1 and supply the clock at pin number 8. So this is what you have to do, and in that parallel mode, make sure that you have set the shift register to this value. I mean QA, QB, QC, QD, or you are getting as 1, 1, 1 and output as 0. Then you need to change the mode of operation from parallel to serial. Even I have explained this, how to do this even in the previous videos or in the laboratory. Now after changing to serial, just your job is to apply the clock. Now apply the clock, and once you apply the clock, you need to observe 0 in QA column, QB as 1, QC as 1, QD as 1, and you should see 0 as a D value. After verifying that, again you need to apply the clock. Okay, this is just a clock input or clock count 3, 4, 5. Then you need to observe the respect 0, 0, 1, 1 in QA, QB, QC, QD, and you need to see 0 in the D column. So like this, you need to verify each and every cases up to 15. And when you apply the clock at the 15th time, you should see 1, 1, 1, 0 in QA, QB, QC, QD column, and you need to see 1 in the D column or the output pin. Clear? So if you are getting this, then I can say you have successfully completed the the experiment. Clear with this? So this is what you need to do in case of sequence generator, right? If you have any doubt regarding this, you can contact me. So thank you, Ananda.